we have some good concepts on inheritance now, hopefully. Okay, you might not feel totally comfortable with them yet, but the next step is how do we code it? The back and forth hopefully will help a little bit here. If you're an abstract thinker, you might be like, yeah, I totally got this. If you're more of a procedural, concrete approach, you might be like, I have no idea what you're talking about. It's okay. Let's mix through it, look at how we implement this, and then we'll go back and forth between the concepts and then the implementation, and hopefully between the two we'll get a little bit better feel for how inheritance impacts our code. And the concepts are very important. For now, we want to focus on the implementation. So going back to the UML, when we see a class that's abstract, the way we identify an abstract class in UML is the name of it is going to be in italics. So when you see product here as opposed to food, you can see it's a little bit slanty, it's italics. That means, or you have the stereotype up there, by the way. That means I have this word abstract that comes somewhere in the class definition. So public abstract class. I could have abstract public. The order of these don't matter, but typically you say public abstract class. The name of the class is product. That makes this class abstract. That's all it does. I do not have to have an abstract method to be an abstract class. If I have an abstract class method, I must be an abstract class. Okay? That's the only new syntax we'll be learning. There's the word abstract in front of class. The inheritance definition right here, the little triangle we see from UML, is realized through the word extends. And so after I define a class, public class food, food extends some other class. Just the name of the other class right there. That's it. That realizes that line right there. Now it has all these ramifications we'll talk about. That means that all of a sudden all the attributes from product are part of food. All the methods that are part of product are part of food. All the constructors that are part of product must be something I must account for as part of food. We'll see that later on. But that's really the only two new bits of Java we're going to focus on for the moment. It's real simple inside of there. We'll come back to a few more. There's not a ton of it here. That's the concept here. So an abstract class up top is the grouping. The class down here implements it. This class does not have to be concrete. I could have an abstract class here. I can have multiple layers of abstract class like we saw in our syntax above, but that just means I extend that abstract class, I get its stuff, and I still can't create instances of it. We'll get back to that as we go. So the parent resources then is something that's available to the child class. Anything that's up in the parent class, all the attributes, all the methods, is something that can be called. Now, it's called implicitly for most of the stuff. So when I want to, if we go back to the previous slide, down here, if I want to go as part of the food class and access the price of the food, I can just say price, just like I would for any variable inside of food. The whole object has all these things squished together. It means there's actually some rules inside of there where I have to be careful the way I name things, which is what we see here for toString. It's legal for the parent class to have a toString method that prints out the price of a product. Product price, that's the only thing we know about a product at this point. But it's also legal for the food class to change the behavior of a toString. We'll get to this more in future classes, but this is called polymorphism. So let that word sit there, polymorphism. But we'll come back to that and explain it more. But when I change that behavior, that means I have to be able to differentiate between the behavior I have in my food class versus the behavior that's up there in my parent class. And the way I do that is the keyword super. Super says to Java, don't call my toString, call the guy who comes from a toString. So don't run my hairline method, because that right now is full and thick. Go to my parent's hairline method and see if that's going to continue to be full and thick or whatnot. That's the inheritance side of it. It's saying I want to get behavior from up above. Now, when I am going through and seeing things from my parent, there are ways for the parent to hide things from even me as a subclass. When in the product class I make things private, private means I can only see everything from the opening curly bracket to the closing curly bracket. My parents are allowed to hide their secret past from me. That's perfectly okay. But that means I cannot use it. If I say super.price down here in the toString class, I cannot call super.price. I cannot see that value because it is private. So you have to be accounting for that. Now, what are my options? I can, in a parent class, create a variable as being called protected. And that's saying not everybody can see it, but certain trusted people can. So specifically, any class that extends product has visibility to a protected variable. So the protected variable here says, okay, when I say super.price, that's okay. That's a call I can make. Now, why would I want something protected? Well, I might want to keep encapsulation. I want to keep the price something that's true for all products. And I'm only going to allow you to get the price by calling getPrice. So that way I can do some shared behavior, just like I would in any other object. Just because we throw in inheritance doesn't mean we throw out the class hierarchy, the encapsulation, the data protection, all that sort of stuff. It just means I have a choice. I can either protect it or share a little bit of it, or share all of it, as we can do if we make it public. So there is some rules around this that makes it pop up. So inside of it in general, protected that we just learned about means that I am going to share that variable with anything in my class, anything in my subclasses, or anything in the same package as me. So if I'm in the product class, there's some other class in the product class, I can see it. I can see it as a subclass anywhere. I don't have to be in the same package. That whole class thing in the same package is not commonly used. I would not really use it all that much. I wouldn't count on it. It's not something you really want to design with that much, but it is a reasonable rule. So that's the protected status inside of there. The default status is when it means I don't put anything inside of there. If I use the keyword public, protected, or private, that is setting an explicit status. If I don't use anything, if I just say double price, that's what's called default. And my recommendation to you is never, ever, ever use this. It's confusing. It's confusing code. I honestly, if it was my language, I would have taken it out of the language by now. There's no real good reason to have something with no word inside of there. I would have just called it package or something inside of there, or just not have it at all, because I don't know why you need to share stuff in the same package. That's a goofy rule for the way, so just basically don't use it. But that is a rule in case you were curious about it. Default, if you put nothing inside there, says any class in the same package can go and access this sort of stuff. The one we're used to saying is private, which means you have to be in the class that you are in order to be able to have that. And then public, as we said, is anybody. I mean, it's hard to represent it. That's why it's a dotted line. Just anybody anywhere can see that variable. So most of the time you probably use private and public. Now we're introducing the idea of protected. Protected goes along with that keyword we just talked about, super, which gives me accessibility to the things above my hierarchy. And then that's because of the extends keyword we talked about to begin with, which ties into the abstract class. So those are the new bits of Java you'll be learning. We're going to practice those and play with those when we get to code examples, but that's at least you can see them and see how they fit into the design we've talked about so far.